Welcome everyone. This is the first lesson recording for IM1, October 13th, 2020. We started off by doing quiz number 4 on negative and zero exponents linear relationships. So if you missed the quiz because you are absent, please contact me as soon as possible so that we can arrange a time to meet to make up the quiz. Unit test correction. So you've had one unit test. If you did not do well on that test, it's drawing down your grades a lot. So if you scored lower than 80%, you have an opportunity to make an appointment to meet with me to go over your test together, in which case you may earn up to 10% of your missed points. So meaning, say if you earned 60% on your unit test, then you missed 40%, and 10% of 40% is 4%. And so if you work with me, and then you could earn back up to 4%, so your grades will go up to 64. And you might think that's not a lot, but currently it's going to bring up your grade by a whole percentage or probably more, because it's drawing down your grades a lot. So please make an appointment to do that. Also, do you read my feedback from your homework? What I am finding is that I make the same feedback and it doesn't seem to make any difference. So I'm wondering if you're actually reading it. So when I am grading your homework, I usually make annotations if there is any corrections to be made or any major misconceptions, or in this student's case, he's not showing much work. Okay, so if that is the case, I am going to annotate it as well as leave some feedback saying, hey, you need to show more work, or there are some misconceptions that I see. Please check your answers against my answer key that will be provided. Okay, so there are feedback here for you to make any changes. If you keep making the same old mistake, then you're going to keep losing the points. You should be getting 10 out of 10 for each of your homework. If you're losing any points, I usually try to leave some comment. And even if you're getting 10 out of 10, I might sometimes leave you a comment. Now, you're not necessarily going to get notification that I left a feedback. Where are you going to find that? Is when you go to your IM1 grades. These are all your grades, and this is my test student, so he hasn't been doing much homework. So in this case, so next to the score, you should be able to find some buttons here, and one of them should give you the teacher left your feedback. Okay, and if you click on that, you should be able to see what I said as well as your scores and everything else. All right, so what are we doing today? We are going to look at new situations other than tau patterns and relate slope, y-intercept, growth, starting value in different representation for different linear situations. So we are still continuing with linear equations. So to do this, we're going to start off with a fun exercise. We're going to see how many times can you clap in 10 seconds. So I am going to be timing 10 seconds for you. So I'll say start and then stop. So within that time, you're going to see how many times you can clap. Okay, so you just need to count in your head. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10, so on and so forth. Okay, and we'll do this twice for accuracy. The first time, you might not really get the feeling, but for the second time, hopefully you'll get accurate data. Okay, and then you're going to enter that result into the Desmos card in card number 1, and we will get the result from everybody else as well. So if you were absent, these are the links. So you're just doing card 1 and 2 only. All right, well, that was fun. Okay, why did we do that? To watch this video. Hey, that was pretty cool, right? I thought it was anyway. Okay, so you are now going to continue with card number 3 to 10. But as you do this, for card number 4, when it says using Desmos math box, it's not the text box, it's the math box. You can use this For multiplication, you can use the star, which is on top of shift key of number 8, or division will be replaced by backslash, or exponent is that caret. Okay, and math box will actually do the calculations for you. It's like a calculator as well. If you put in the expression, it will actually do the calculations. So please pause the video and complete card number 3 to 10. Okay, so I am going to assume that you watched the video again and have an opinion as to whether he will break the record or he will not. Then let's move on to the next one. Okay, Saeed noticed that Brian clapped 62 times in 4.5 seconds. Using this information along with some math reasoning, answer the question. How many claps will Brian get in a second? So if he did 62 times in 4.5 seconds, we want to know in 1 second. Okay, so 4.15 seconds he did that 62 times. The expression will be 62 divided by 4.5. And when you do that, the math box will actually calculate for you. And I got 13.7778, which is approximately 13.8. So this means that Brian will clap about 13.8 claps per 1 second. Alright, for the current record holder, how many claps did he get in a second? So current record holder is 721 claps per 1 minute. Okay, so this is for 1 minute. How many seconds in a minute? 60 seconds. So he did 721 claps in 60 seconds. So how many can he do in 1 second? We will do the calculation of 721 divided by 60. Like so, and that's approximately 12.0167. So with this new information, do you think Brian will break the record? Explain. Okay, so the current record holder is clapping 12 claps per second, while as Brian, we found out from the previous card, was clapping 13.7 or 13.8 claps. So he's clapping more claps in 1 second. Okay, so do you think he will break the record? I hope so. Okay, now here is a graph modeling the current records holder's clapping behavior. Okay, look what's happening here. He's starting with 0, and then when at 60 seconds, he has, this is 600 and this is 800, so 721, I believe was the number, is approximately here, and that's where that point is. Okay, so based on the model, approximately how many claps would they be doing in 40 seconds? Okay, so in 40 seconds, we're talking about time being 40 seconds, so we need to go to 40 seconds here and then go up, find where the graph is meeting at 40 seconds, and then go across, and it's approximately here, which is between 400 and 500, closer to 500. So maybe I can guess like 375 claps. Okay, and I will submit that. Okay, and then it says to select your line drawing tool and set it to green, then sketch it where you think Brian's challenges graph would look like. Okay, so we said that he was able to clap how many in 4.5 seconds. So Brian clapped 62 claps in 4.5 seconds. So 4.5 seconds, that's 10 seconds, that's 5 seconds. 4.4 seconds will be 4.5 seconds will be here. 6.62 will be approximately here, maybe slightly beyond the graph. So my guess is it's going to be close. And I'm going to use green, set it to green like so. it's going to be close. Let's undo that. It's going to be close from he's starting from 0 claps, but I think he's going to be able to do a little bit better, maybe just slightly better like that. Okay, that's my guess. All right, so then reveal, push play to watch, and when you watch this, it's actually going to give you the time, and it's going to graph it at the same time. Okay, so at 1 minute, there's that point how many he clapped, and that's my green line. Okay, so as the time elapses, he keeps on counting how many he is able to clap within that time, and the green dots represent how many claps he has done. Okay, so he has broken the record, and let's see what he's going to finish at. Okay, so he finished at 802 claps in 1 second, or in 1 minute. So that's the graph of it. The green dot represents his graph. Okay, so if you model Brian's clapping event with a continuous line, the equation will be y is equal to 13.8x. Notice that there is no number being added. Why? Because the y-intercept is 0. He's starting at 0. Okay, so what quantity does x represent in the situation, and what quantity does y represent? Well, x-axis represents the time. So I am going to write, this is time in seconds. And what does y represent? It's number of clap. Spelling. Okay, still not. Okay, number of claps, and that's from the y-axis being that. So what is the slope in this equation? Slope in this equation, remember, slope is always the number right in front of x, the number being multiplied to x. That number is not being added to x, it's being multiplied. So it's 13.8 times x. The slope is 13.8, and it does not have the x attached to it. It is the number in front of it. Y-intercept is, we have no y-intercept. That's why it's a plus 0. So it's 0. It's 0 is the y-intercept. Then you submit. Okay, and then number 9. Where have we already seen the slope of 13.8? Where have we seen that number before? Well, 13.8 from the equation y is equal to 13.8x represents what? In this case, it represents the slope. But from card number 4, it actually represents the unit rate, which is the number of claps. I can't seem to, claps per seconds. Okay, so that's what it represented. Okay, if we evaluate the equation for x is equal to 20, so if we used 20 as the equation, or you can go to the graph and find the y value here, then what does it tell us? So y is equal to 13.8x. So, and that's going to be when x is 20, it's going to be 13.8 times okay, that's going to be 276 claps. So that's how many he would have after 20 seconds. Okay, and the next slide is where you filled in your data and calculated your unit rate as well as graphed. Okay, we'll continue in the next lesson recording for the next section.